Welcome to the Business of Engineering, the new podcast from Element 14, the world's largest online community for makers, engineers and tech professionals. In this series, we're going to be talking to entrepreneurs and business leaders about some of the challenges and opportunities involved with working in the tech sector. I'm happy to be joined today by Leon Doyle, CEO of Wi-Fi Plug, Dan Burton, Entrepreneur Acceleration Manager at Natwest Entrepreneur Accelerator, and Joseph Crabtree, CEO of Additive Manufacturing Technologies.
Good afternoon, my name is Joseph Crabtree, CEO of Additive Manufacturing Technologies. We are a company based in Sheffield and we also have manufacturing facilities in Europe. We are a company that's based in the 3D printing industry. So just to give you a bit of background about specifically what we do. So we solve 3D printing's dirty little secrets. So 3D printing at the moment consists of a whole bunch of unconnected processes that actually potentially erode the benefits of 3D printing, i.e. they're not digitally connected. We actually design, manufacture and sell technology hardware that enables the digital thread to be preserved through additive manufacturing. So we basically unlock the potential of additive manufacturing. At the moment, we're concentrating on an area called post-processing or finishing, which is the bit that occurs after the printer. And at the moment, this consists of a whole bunch of manual disconnected steps. And those steps can consist of anything from sanding the part, painting the part, and all of this is done manually. So our technology, in essence, enables people to take the as 3D printed part, put it in one of our machines, and a number of minutes later you get the part. So this really is an unlocking technology that enables the industrialization of additive manufacturing technologies.
I'm Leon Doyle, the CEO of Wi-Fi Plug. We are an app-controlled smart plug, or at least that's how we started out. And currently we have shipped over 50,000 units, and we have partnered with Apple. So we have the MFI license. So you can say, Siri, make me a coffee, or Alexa, turn the lights on, or hey Google, turn the fridge off. As you can see, there's no use case for these plugs whatsoever, but somehow we've shifted a few. We have a full team in-house of software engineers, hardware engineers and sales, and we've got some interest from around the world, so we're constantly flying in and out of different countries talking about our products. And the most unique benefit which we have is that we are the only smart plug on the planet to pay for itself. So what I mean by that is we have a patent that it can start to shut down standby appliances because it knows where you are in relation to the appliance, whether you've left the house, whether you're asleep, and then it can show you in real time how much money it's saving you in the app.
That's cool, man.
Thanks.
Hi, I'm Dan. I'm an acceleration manager here at the Natwest Entrepreneur Accelerator in Leeds. We are a network of 12 hubs across the UK that provide fully funded support, advice and mentoring to startup entrepreneurs and entrepreneurs of businesses of all shapes and sizes.
So the topic of today's discussion is manufacturing. Obviously, Joseph, this is something that's very close to your heart because you are a manufacturing business.
Yep.
So how does your manufacturing process work?
So when we started off, everyone warns you not to go into manufacturing, but actually, a lot of people can sort of stay in the sort of software development realm and then maybe subcontract out the manufacturing if they're building a product. Or if they're just doing software, then that's quite easy. We decided to do everything in-house. So we do all of the design, that's both of the sort of engineering design, that's all of the electrical design, and then we do all of the manufacturing in-house as well. So it's a big undertaking. Dealing with atoms is a lot harder than dealing with bits and bytes. But we feel that gives us something quite unique in terms of not only do we have the IP that's inherent within the product, whether that be patents or trademarks, etc., but it gives us that manufacturing IP as well. So it allows us to bring product to market a lot quicker than our competitors because most people do subcontract, especially in the 3D printing industry. And it allows us to be in control of our own destiny, whether that be from a profitability point of view, from a time to market point of view, or purely from a protection of IP point of view as well.
And was that always going to be the case? Were you always going to self-manufacture, or was that a decision that came along a little bit later?
So I think that's a good question. So my background is manufacturing, so 10 years of manufacturing in the aerospace or high value added industry, so aerospace, automotive, defence, off-highway industries. So I really understood what I was getting myself into. It wasn't a trivial decision. And I think that from the outset, we wanted to have something that was a bit unique compared to any potential competitors. And this, having the manufacturing capability, gives us that.
And Leon, what's your relationship to manufacturing at Wi-Fi Plug?
Yeah, well, it's a means to an end, and we have to do it because otherwise people wouldn't have the hardware. We really treat the hardware as a gateway to the data, but absolutely it's imperative to our business. And so we have working relationships with an Apple certified factory in Taiwan. And it's not the first factory we've had. In fact, it's the fourth factory we've had. So you can see we're doing things right. We're definitely creating the right kind of relationships, long and lasting, and really nailing that. It's not something I really enjoy. I don't think we're having much luck, to be honest, with our manufacturing partners.
Mm-hmm. What have been some of the main challenges that have caused you to have to go through 4 different factories so far?
So actually going through 4 different factories has 4 different answers, but it's as we started out, it was more of a shoestring, so bootstrapped. We were very much using other people's hardware or molds, if you like, the casing, and cutting costs that way. And then by the time that product had sold enough for us to self-build our own tooling, we moved to another factory, and then we had everything was fine there, and then we introduced a brand new product, but they couldn't build it, so we had to go to another line or another factory with another line. And then finally we got approached by Apple, who wanted to put a co-processor chip inside our units, and it was really good news for us, and we had all the factory and all the tooling and everything, and we told our guys, our factory, about it, and they said that they couldn't do it because they weren't Apple certified, so we had to move again to another factory. And we couldn't actually use our existing tooling because the Apple co-processor chip was 1 millimeter too big for our casing, so we had to retool. So yeah, it's been a tough ride, but we got there, and obviously we're Apple certified, which is pretty awesome.
Sounds like 3D printing's the ideal solution in that scenario.
Yeah, absolutely. Well, we've done all the 3D printing, of course, for every single one. We mock them up a good couple of times, maybe 4 or 5 times, T0, T1.
Okay.
But, yeah. I mean, 3D printing really has only come into its own in terms of relative cheapness or cost efficiency now. Like the last one we did was maybe, I don't know, 6 months ago.
Yeah.
And that was so much cheaper than 5 years ago. So I'm really pleased to see that the cost has come down.
And then you'd be able to manufacture custom products in the future.
Well, wouldn't that be nice? We were actually, honestly, we wanted to do a kind of a print-on-demand service. So if they don't need it, or when they order it, their 3D printed model goes in and comes out the other end. But as you'll know, there's issues with certification and fire retardant products and plastics. But it would have been nice to do that.
Dan, is this kind of a familiar story that you hear from when you're working with tech startups, that they do have this struggle to kind of find the right manufacturer and then to find one that's going to serve them through their entire lifespan?
Yeah, absolutely. We see lots of businesses in here that have products, be it tech or otherwise, that need a partner for manufacturing. A lot of the issues that our entrepreneurs face is working capital, so having enough money to put in the minimum order quantities that a lot of the manufacturers require. Also the capabilities and capacities of that manufacturer. Can they sustain and meet the demands of the entrepreneurs as they grow? So it's not just can they do it now, but if in 12 months they're sort of selling what they need to and what they're projecting in terms of their forecasts, can that manufacturing partner continue to serve them? And as the guys have said, every time you change partner from a manufacturing point of view, particularly if you have tooling, it's a significant cost, and each of them is typically bespoke to that manufacturing partner.
Yeah, so just as a comment to that, so we, a lot of product is tooled, whether that be for injection molding, whether that be even for sheet metal forming, whatever the process may be. And I think one of the biggest troubles or problems for companies, if they're going to go into the manufacturing space, is that if you don't have a manufacturing background, and even if you're going to use a manufacturing partner or subcontractor, how do you know what you're really asking for? If you don't understand injection molding as a process, CNC machining, forging, whatever the relevant process may be, how can you be an informed buyer? So I think it sort of even goes one step back, is that if you are going to get into that sort of manufacturing space because you've got a product, you need to be well informed, because people might not understand this concept of tooling, that you might have to buy the tool to manufacture the product, and then if you've got a small design change, you can't make it. And I think that's a big hurdle, and there's probably some, for people from non-manufacturing backgrounds, there's some sort of education required around that. But our view was very simple, is you design the product that doesn't require tools. So in essence, you're creating something that doesn't have to be tooled up, so we don't need to invest in tooling. That's inherent in the design. So we look at everything as if it's a one-off, but with a view that we could scale it up to high volume manufacturing. So again, I think it's just about understanding what you're trying to achieve and how you're going to achieve it. And if you've got a view of your long-term plan, because ultimately, as you probably know, Leon, is that if you're going to scale it that high, you might license it to someone else anyway. So you've got to understand your future model. And we're not going to be competing with someone who's going to produce 100,000 units a year, but at this stage in the business, it makes a lot of sense to be producing what we're producing, because our products are relatively, probably compared to your products, low volume, high margin, compared to something that's maybe produced in the thousands or tens of thousands, for example. So probably a very different business model as well.
Yeah, I would say, and also like the factory, you have to move with your factories. As you start to grow, you can't expect that same factory to facilitate 1 million units because they're just not built for it. So you will move, and you do take your tooling with you, and that is the natural progression, I guess, for any startup or established business. But it would be amazing if we could 3D print these and not have to worry about tooling. It weighs a ton as well, so just moving it costs about 10 grand. And it's a real headache, and it's not my background, as you point out. It makes perfect sense, and that's why we've hired hardware engineers that have got experience in manufacturing. In fact, one of our guys, similar to you, has an aviation background, so they know it all, and so that you do save a lot of time there. If I was to go in blind and just be like, I think we need some tooling to do this, you just get your hands, you'd be fleeced, wouldn't you?
You waste a lot of money and waste a lot of time, and you're not concentrating on the important things in your business.
I'd also like to add that as you grow with each manufacturing partner, the commercial relationship that you enter with them doesn't always stay the same. So you may contract or subcontract the manufacture to someone, you may license it to another party. As you develop, you may want to go into a JV or some sort of cooperative with the manufacturing partner whereby they take some of the profits, or there's lots of different arrangements, not just sort of subcontracting. And then obviously if you get big enough and you can afford the capital, then you can actually develop the manufacturing process capability in-house.
Because I think also for our products as well, we're talking, as I said, relatively low volume, high value assets that are going to be installed in people's facilities. So it's a piece of equipment, it's potentially a piece of CapEx equipment, and that CapEx equipment needs to be serviced as well. So there's an after-sales element. And if you then, these products go into industry, into multi-billion-dollar companies, there's a certain level of after-sales expectation as well. So if you manufacture the product yourself and understand what goes into it, how it works, how it interacts, you're in a much better place to actually service that from an after-sales point of view as well, rather than having to use a subcontract after-sales team and do all of that. Because if you subcontract the manufacturing, you probably don't really know what's gone into it.
So when you first kind of came into the manufacturing stage, can you tell us a little about kind of what initial research did you undertake when you had that first prototype that you wanted to then take to manufacture?
So very little, to be honest. It was just an idea at that stage, and just got that burning passion to build something and make it happen at really whatever cost. It was only fortunate to the fact that I'd sold my last company, so I actually had some capital to play around with. There's no way, as a startup with zero cash and no investment, you could actually ever have done what it is we've done because of the cost. They're just so crazy high. So starting out actually was a bit easier for us because we didn't have to worry about the capital expense of tooling. We used someone else's mold. It was actually from an Ethernet Wi-Fi booster, but we kind of just changed the look of it a bit and put our logo on. So that was a better way of doing it, if you like, but it didn't sit right with me because it wasn't our product, it wasn't our IP. We could get it a lot smaller, and so when we finally got the sales in and covered the cost of sort of the first R&D phase, then we began to tool our own product and make it the world's smallest smart plug.
I was good. Just on tooling itself, often when you contract manufacture or you get someone to manufacture for you, they might quote the cost of tooling, but you need to make sure that the ownership of that tool is yours, because some manufacturing companies will keep that, and if it's something that you're trying to protect the IP, the design, then down the line they may be able to release cheap imitations.
I think a lot of tech startups probably do. A lot of them start with this idea, and that doesn't necessarily mean that they're going to have a whole raft of back knowledge about how the manufacturing industry works and the pitfalls, etc. So is it just a steep learning curve? Did you have any professional advice that you sought out in terms of preparing for it?
It's just team. You've just got to assemble your team and make sure you get people with credible experience that have been there and done that, because there's no way you can't just spin all these plates. Yeah, you can't fake that. You absolutely can't. I mean, the entrepreneur's motto is sort of fake it till you make it, but when it comes to something like as serious as tooling and hardware, you cannot fake a real product, or you can and it won't work, and then it's very obvious that you faked it. So we just assembled our team, and that's what drove the whole thing forward. Couldn't have done it just by myself.
How do you say the manufacturing industry has kind of changed over the past maybe 10, 15 years that you've been in the industry?
So when you're working for multi-billion-dollar corporations, manufacturing's hard enough as it is. But you've got access to the best equipment. You've got no working capital constraints, etc. And I think that my background has predominantly been what I consider traditional manufacturing, so CNC machining, forging, injection molding, i.e. traditional manufacturing. And I didn't really come into 3D printing until probably 2 to 3 years ago, and really had no knowledge of 3D printing. Knew that it existed, but no sort of detailed knowledge. And really, in terms of how manufacturing's changed, is that these enabling technologies like 3D printing are actually democratizing manufacturing. Because before, the only way to manufacture something would be to get a tool made. You'd have to manufacture 1,000, 10,000 of minimum order quantity, etc. Technologies like 3D printing have actually completely changed the landscape. So now people in their bedroom, instead of just writing software, can be a maker. They can produce a prototype relatively cheaply, go to the local makerspace. And I think that's a big fundamental shift in manufacturing. 3D printing will be the next industrial revolution. It's not going to happen next year, but in the next 5 to 10 years it will be the next industrial revolution. But in terms of how that's affected us specifically, it hasn't, because although fundamentally we're building stuff and machines and equipment that goes for the 3D printing industry, it's not in itself 3D printed. We use traditional manufacturing processes, whether that be CNC machining, welding, sheet metal fabrication, electronics assembly, automation, all of this kind of stuff. So we're building enabling technology for the 3D printing industry, but we're not using 3D printers to build that technology yet. Mm-hmm. Saying that, we do print some of the components for our machines, but it's a very small amount. But there may become a time where actually 5-10 years that might be a higher percentage.
Mm-hmm. Well, given that you are 100% in-house, how do you go about kind of future-proofing that to make sure that you do always manage to stay ahead of the changes in the industry?
So in my view, the traditional manufacturing will always be around. So there's certain things like sheet metal fabrication, CNC machining, what is broadly considered subtractive manufacturing techniques rather than additive manufacturing techniques. And if you look around you, for example, how cars are manufactured, the fundamental process is the same. The thing that's changed is the automation. So actually future-proofing ourselves up until a point is not about the fundamental processes, which will remain the same. It's about how you streamline, automate, make them more efficient. But then there becomes an economies of scale question, which is at what point do you remove the labour and automate the whole process?
So in my experience working sort of 6 years with companies that do innovation and working with manufacturers and advanced manufacturing as well, the biggest changes I've seen is obviously automation, so trying to reduce the workforce, try and be more efficient through the use of robotics and co-robotics. But also there's a massive change in manufacturing techniques based on the new materials that are being invented, so polymer-based materials and how to actually work with them. But I think the biggest and most fundamental change is the use of data, so actually collecting data and interpreting that and analysing that and using that, the insights from that to inform modifications to the manufacturing process to be more efficient and to reduce waste and to be more productive generally. So historically that stuff, the data around machine usage, downtime, all of that wouldn't be captured, it'd be very manual, but now it's all automated.
So Liam, when you got to the manufacturing stage, when did you do a lot of shopping around before you found a factory that was right for you at the time?
There's a couple of different answers to that because of the roadmap, where we've been, our journey, but I'll just cut straight to the Apple one, so because that's where we are now and we're settled there. But the journey, it was kind of pre-selected because we had a really decent relationship with our previous factory in Shenzhen in China, and it was only when Apple came along and introduced and told us that we had to go to an Apple certified factory that we had to start looking for others. And they sent us a list, but sending a list of manufacturers, there's only a handful to choose from. It wasn't really, it was just point and shoot. Like, all right, yeah, Taiwan looks quite nice this time of year, so let's go there. And we had a few back and forth emails. It's more really to check their language barriers because, of course, you're doing a lot of communications. You want to know that they have a decent grasp of English. We found one in Taiwan, and they were very responsive and they were very cooperative, and we went with them, and that's kind of. It's so expensive to change factories and the time involved and starting out those new relationships that you've just got to get it right from the start.
And was it always going to be in the Asian region? Is that always where you were going to be looking at, or did you look at more locally ones as well? If
I could, I'd manufacture in Leeds. Yeah. I would absolutely love to, or Sheffield, like the Ukraine, anywhere. And now the Ukraine labour and China labour, because of the labour's incentive for China has gone up. you're about level pegging. So there's not much in it, and I would gladly move all tooling to Europe. Just to kind of have that, jump on a plane an hour later, you're at the factory, you can have a sit down, you straighten anything out. It's so much more difficult. Taiwan's like 18 hours away, and you can't be going every day.
You lose days though, don't you?
You do, and that fact, you've got to factor that into your pricing as well, and your margins.
But it's a good point you make about whether if you could have it in Leeds or Sheffield or any other UK city for that matter. And unfortunately, the UK has become a service industry, and we've lost a lot of the money. If you forget the cost base for a minute, we've lost all of the inherent skills, or they're very close demographically to retiring. So actually, even if you wanted to set up a manufacturing operation in the UK, you'd be hard pushed to do it. And yes, you can find some graduates who maybe come out of the university with a great qualification, but there's this big void in between. And cost aside, you would still struggle, in my opinion, to set up a manufacturing facility in Leeds, Sheffield, that would be comparable to China or wherever else it may be. And we chose Europe. We've been very fortunate. We've got about 6,500 square feet of manufacturing facility, and so we do everything in house, and we've got full control of that process. And we've been very lucky because the skill sets that we've been able to employ are absolutely phenomenal, and we would not be able to get those skill sets in the UK. It would be fantastic to have it in Sheffield or wherever it may be in the UK, but I don't think there's enough incentive from the government, from other local authorities to actually really do that. Software there is, or whether that be fintech or all of those other things, but true manufacturing, I don't believe so. And especially in Sheffield, there's a lot of high profile manufacturers coming to Sheffield recently. For example, Boeing are locating their first non-US facility in Sheffield, and McLaren has just relocated their carbon fibre manufacturing from Italy back to the UK, which is great. But these are multi-billion, if not $100 million industries, and the incentives for smaller companies to set up the manufacturing isn't really there. And these big companies have economies of scale anyway, so it's a little bit different. So
I'd entirely agree. I mean, even just the investment around it, VCs tend to steer very clear of hardware, really, because of the capex, like you said, and so they're constantly investing in all these startups, these software startups, which are great, and they are game changers in some cases, but definitely not all. And so, like 95% of them fail. And if an investor just maybe took a step back and looked at some other alternatives, or at least a collection of IoT where it's mixed hardware and software, a hybrid.
And it's, I have this conversation with Dan all the time about investment and attracting investment, especially in the UK. And the UK versus the US, different order of magnitudes as well.
By about 1,000.
Exactly. The appetite for risk in the US is there, whereas in the UK, it's not. In the UK, if you raise £100,000, it's a big deal. In the US, people don't even get out of bed for that. So, to put the point in perspective, so a few weeks ago we won Startup of the Year for 3D Printing Industry magazine, or online magazine, which is great. A year before, the company who won it is a US-based company, not a UK-based company, in the hardware and software space, in the 3D printer manufacturing space. And they've just recently been valued at just over $1.5 billion US, have raised over $220 million of funding in the space of between 4 to 5 years. Imagine a British company doing that. It just doesn't happen in England. And if you extrapolate that, that's why manufacturing is so difficult as well. Because if you've not got those incentives, if you've not got those flagship companies or role models, why would people even think about getting into manufacturing? Let alone, why wouldn't you just go and create the next Facebook or the next piece of software? Because at the end of the day, all you need to do is create a PowerPoint with some nice images. You don't even need to program it.
That's right.
And you can get the funding based on a hypothetical idea. So very different propositions, and I think that in the US there is a real appetite. So when they talk about let's get the manufacturing industry started, let's be homegrown US American, they mean it. Whereas in the UK, I don't think it's words rather than actions, I think.
I mean, the issue is the scalability. Like the US has 300 million people that could buy that product tomorrow. The UK doesn't. So there's also that to factor in. Absolutely. And then there's export costs that are associated with taking your product around the world.
But what would you say is the biggest kind of associated cost with the manufacturing? You've talked about kind of shipping and all the different aspects that would make Europe more appealing. But obviously, there's a trade-off to that, which is the reason you've chosen to base it all in Taiwan. So what are some of the biggest associated costs for you of getting your product manufactured?
Well, I'd say after the cost of setting it up, because these are all sunk costs. You've got to pay for your tooling up front. You've got to pay for the certification.
No credit terms.
Yeah, no, 0 credit terms, yeah. So for a startup, anyway. I don't know what it's like if you're an automation company, automotive. Don't know. Do you get credit terms? I don't know. Anyway, they probably don't need it because they've got enough cash in the bank. So there's a lot of sunk costs, a lot of uncertainty, because you can't release your product until all the testing and certification's done, and that's, again, a big cost.
Ties up working capital for that.
Everything's, it's a horrendous business model. Yeah. But when you actually get it out the door, and you get your customers in, and you get your early adopters, and they start telling their friends, and it just, that's what makes it all worthwhile. But going back to the cost, because it doesn't stop there. You still have to, as I mentioned, go out there once or twice, maybe once a month. But it's the cost of your flights, and first class is expensive, as you'll know.
I'm sure, absolutely.
Why I fly economy. But it's just it's these costs that aren't factored in. The days that you lose, as Joe said, just 18-hour flights there and back. You lose 3 days. You're jet lagged.
It's the total cost of acquisition, which is
yeah.
actually not just the cost of what you're buying, I think.
Absolutely. And then if we were going to go down the whole carbon route and the clean energy, they've got to manufacture it, and the working environments are tricky at best. So there's a lot of hidden costs. And then actually, if you go back into the software, so you've blown all your cash on capital and sunk costs there, then you've got to keep your servers up, get your engineers in, get your team out, and it's just a never-ending cycle. So, yeah, I mean, I know it's not on there yet, but would I advise any startup to go into manufacturing? No.
How do you?
But I say, and my advice wouldn't be as black and white as no, because I think we should encourage people to be in the hardware space.
Don't do it.
It's a good thing. However, you've got to be fully eyes wide open and not naive. I mean, look at Elon Musk is a great example. Incredibly smart guy. PayPal, SpaceX, Tesla. And what he's done with all these companies is fundamentally reinvent and break down barriers in terms of space travel, electric cars, solar city, whatever it may be. And even him, with his unlimited access to cash with Tesla, is still struggling with manufacturing. And he has some of the best minds in the world, access to all of the automation equipment in the world, the best resources in the world, and yet he is still sleeping in the factory at night to try and solve the problems. Now, as a startup with zero access to all of those resources and capabilities, it's incredibly difficult, not least to mention the working capital issue, but everything is a challenge. And when you're talking about hardware, if you get to the end and it's wrong, or you fail certification, you've got to start again. And it's not as instant as software. With software, you can code something, you get a result, you can see it on your screen, look at me, fantastic. Hardware can take weeks, months, if not years, before you get a product out. And that time to market is
crucial.
Yeah, and can kill a startup.
Yeah. And do you know what we've missed out entirely is the bill of materials. Our plug has 179 different components in it. And you've got to source all those from around the world. And one of them's got a 52-week allocation. Some of the ceramics, you put an order in a year's time, you'll get it. I mean, how do you launch a product when you've got to wait 1 year to get one component? It's a real struggle. It's not easy.
Or on the flip side, you've waited your 52 weeks and then the supplier says, sorry, I'm delayed another 20 weeks. Mm-hmm. And then suddenly you can't launch your product. So you're not just reliant on a software engineer coding to make the product and putting in some more hours. Some of this stuff becomes completely out of your control. And if you don't have the runway, and if you don't have the aptitude or the ability to manage these situations, then a startup could very quickly go out of business.
Yeah, so on that point, you've mentioned it a couple of times, which is the working capital. So one of the biggest costs, and it's not really a cash cost, but it's more of a timing difference, is you might have a 52-week lead time on a part, and you've paid for that typically up front. You've committed the cash, but you can't sell anything for that period of time. So a lot of businesses, you've spent all the money up front, you've made your minimum order quantities, but then you have to wait to receive the parts, which may be several weeks, and then you have to sell the things, and you may not get the cash for several months after selling the part as well. So, you could have, even just in the case where you're selling a fast-moving consumer good to a supermarket, there might be 4 months cash deficit that you need to fund. And whether you fund that through equity or debt or by any other means, that has a cost as well, which a lot of people just don't consider.
Quite right, yeah, quite right. So it's just for us. I mean, we appreciate all our customers out there that have stuck with us, and actually, one of the ways we have managed to stay afloat, or at least keep our burn rate there, is by in the olden days before it was launched. telling our existing customers how amazing this product is and how we are the world first, and having them sort of back us, almost like a crowdfunding type campaign. I mean, crowdfunding itself is a revolutionizing product, but we didn't do it on the real CrowdCube. We just told our customers, look, it's coming. It's going to be the world's first. It's the best. You can set it up by scanning your iPhone or tapping it on the side. And people love that, and they just backed us in that way. So there are other ways to get the cash. And I wouldn't say cash is the biggest obstacle. In fact, I'd say it's probably the smallest when you look at all the other problems that manufacturing presents.
And it's, because if you in the 3D printing industry, there's a great example, a company called Formlabs, which at the time was the largest ever Kickstarter raise. I think they raised about $13 million. And they genuinely didn't expect they were basically created an SLA desktop printer. So it was game changing at the time. And it was for sub $2,000 or whatever the price. So it's accessible to a whole new market. They got all these orders, great. They raised the money. But then obviously that money's not yours. You need to then spend it to build the product, to sell the product, to give the product, in this case, to the customers. So their issue was a scalability issue. So it's not the cash. They had the millions in the bank account. So how do we subcontract manufacturing?
How do you find the right factory
exactly,
to handle
quality
that
of the components? And then their battle was, and there's a great documentary called Print the Legend on Netflix, if you get a chance to watch it, that documents all this. But their battle was then talking to the customers, oh, sorry, we're delayed another 6 months, another 18 months. And it's about that goodwill at the end of the day. And how do you keep the goodwill of the customers or potential customers going? Good news story now, they're worth about $800 million. That's great. They've got across those hurdles. But if you don't have the team, if you don't have the aptitude, if you don't have the ambition and the desire to do it, then you'll just fail at these hurdles. It's tough.
Yeah,
it's tough.
It's really tough.
You mentioned a few times there your challenge of putting together that bill of materials. Were there any kind of compromises you had to make to kind of get that cost effective?
Yeah, I mean everything's a compromise. Yeah. Every single component. It's we can get this 10 MFU on a 20% tolerance for X price, or we can go on a 10% tolerance and it's 5% cheaper. Everything is a trade-off. Every single thing, because there'll be another component that will do the same job, but you don't want to take the feature and the form away, and you don't want to reduce quality. 'Cause if we're a premium Apple product, you can't be taking bits out and replacing it with substandard components, because you can get hold of substandard components, just like you can get a cheap car and an expensive car. But it's how you feel and your ethics and your company's brand and where you want to take it to the future, and are you willing to compromise on those components? And sometimes we're not, but sometimes you can see other products coming out of China where they clearly have. In fact, we pulled open a smart plug that we got sent to us by a customer who bought our product, because they also bought a cheap product. They bought a cheap smart plug, and we actually said, if you send it in, we'll send you one out with a discount code. And we were fascinated. We couldn't believe it. In fact, we've got a blog on our website. You can find it. We opened it up, and I think we've got 159 components, or 172, something like that. It's a hell of a lot. And we opened this one up, and we were greeted with the antenna was basically just some wire wrapped around a piece of cardboard in an electric plug. So it's just, which is remote controlled. Yeah. So it's like literally a remote controlled bomb that they had, and they sent it to us, and we wrote about it, how you can cut corners to build the same product, but that is, it's how do they sleep at night, and that had no certification whatsoever. And there's also an issue with that, with the global trading. You can buy a product from China with 0 certification and use it in your house, but
look at the hoverboard example. And quite more often than not, they'll put CE on it, which basically stands for China Export, not for the CE European mark, which is a well-known, which they did on the hoverboard. So people assume it's CE approved, not that CE approval really means a whole lot. But
how do they tell the difference? Because I've been fooled by that.
Well, you don't. I mean, that's
trading
the problem.
Standards.
That's why UL is a register, so you can look up and check the company. CE self-certification, so that's a problem. But there is still this balance between getting the components right and producing this ideal perfect product. And if you're obsessed with producing the perfect product, you'll never bring it to market. And by the time you do bring it to market, it's too late because someone else has done it. So there is always this trade-off, but it's not at the cost of getting cut price components that are not fit for purpose. It's about getting a product that's a minimum viable product, so you can actually start generating revenue. Because in an ideal world, you'd sit there and design it and test it until it's perfect. but then no one's ever going to use it because it'll never come to market. So I think there's a trade-off, but you cannot compromise on stuff, especially when you're talking about electrical safety and stuff like that.
That's obviously another big issue with manufacturing, particularly manufacturing abroad. How do you make sure that the product you're creating is compliant with all the necessary standards? Did you need any particular guidance on that?
Yeah, I mean, there's huge amounts of compliance, and the BS standards, the British standards, have for a 3-pin plug, they're very, very strict, more so than America. I mean, UL is a more strict anyway, but yeah, there's like 100-page documents that I will, I don't read, but that's why you have people in your team to do that for you, and also you outsource all of the testing to like Intertech or a testing lab. You don't do it in-house. Well, you do to build the prototype and the original, but then it goes to Intertech and they sort of do all the proper testing.
And that's because you've got a small product, but with our product we do all of the testing in-house. So we do, because it's for a sample product, they can't obviously put it into the laboratory, so we actually have to pay for the engineers to come out into our facility with our test equipment, which needs to be calibrated by ourselves, and we need to do all of the testing ourselves, which gives us a great skill set, but obviously you can imagine the cost associated with that.
Is there not something that's ringing in the back of my head is like the Volkswagen emissions test? Like they had their own testing system that said it was fine.
Perfect, yeah.
And then they took it to an MOT station in Leeds and they're like, no, that's horrendous.
No, so with all of that testing, it's, you have oversight by the UL governing authority. You have to fly them out. They have to come and witness everything. So it is, and everything needs to be pre-calibrated by an approved UCAS certified laboratory in the UK or the European equivalent. So a lot of cost, time and effort, but that's why the UL standard's held in such high regard and allows you to be confident in your product, I guess.
Yeah. Well, I didn't know that. I didn't even know you could bring them in. I thought you had to get it done outside.
No,
okay.
Bring them in. Yeah.
But I mean, still doing it outside costs a bomb.
Absolutely,
and time.
And time as well.
Yeah.
It's not an instant thing.
3 months. Yeah. And then if it has to get redone. Yeah.
And when we talk about design, it's not just about the physical mechanical design, it's all of the electronics design.
The frequency,
everything.
Stuff you can't see.
And all of the stuff that you may take for granted, like the frequency, the EMC emissions of something.
Yeah.
Stuff that you take for granted with a phone, but that will have gone through, whether it be noise emissions, in our case, industrial equipment, and the amount of legislation that you need to comply with, just for example, that water cooler in the corner will have had to have gone through so much legislation because electricity, it's water, it's, so it's a minefield, but you need to, as I said, eyes wide open, I think.
Joe, is there any way to reduce the risk of failing UL? Is there any sort of pre-assurances that you can get from them in, say, early stage prototyping?
It's a very good point. So with UL, you can do what's called a preliminary audit. So you pay for them to come out and assess your product and audit your product with a view that they will ultimately be certifying, and they'll give you a whole bunch of feedback. But that is a mandatory process, but it's not cheap, and everyone should go through that process. So
mandatory or elective?
It's not a mandatory process.
It's not, okay.
But they suggest it because it de-risks their side. You can de-risk your development cycle, but you could still go through that process and still find you've got a product and still find you've got 9 months worth of development work ahead of you because you've got the wrong components or wrong layout or whatever. And just in terms of how detailed that goes, this goes down to the thickness of all of the individual wires you can use, how you label each of the individual wires, how you space the components in an electrical cabinet enclosure, how the cooling works, so you get one of those things wrong and your product fails. So even though you might have a whole assembly full of UL approved components, if the assembly is not UL certified, then you'll fail it. So it is tough. It's difficult.
Thank you.
It's honestly a wonder, like, we actually got our products off the ground, isn't it? Like, it's so difficult.
Yeah,
it's so difficult.
And I wish is that, I know your advice is no, don't go into manufacturing, but I think to your point about investors, it's probably because it's not encouraged. You don't see in the investment community, and especially things like Northern Powerhouse Investment Fund, or look at this company we've invested in, it's a manufacturing company. You might get a CNC company that invested £200,000 in debt to buy a new CNC machine. But that's
not
different.
An investment.
And that's not a risk, that's not an equity deal, it's not a risk investment. And I think if there was a flagship company and investors got more comfortable with it, then there might be more desire to go into manufacturing. But unless the environment, the UK environment, is fostering of that, then I don't think it's going to be, I don't think people are going to jump into it.
So how do you manage that cost? Because we keep cycling back to this, the insane cost of keeping all these plates in the air. So how do you actually manage it? Why are you still here?
I honestly don't know.
Failure's not an option.
Failure is not an option. Yeah, we just got a huge overdraft. So how do we do it? Well, as I said before, I exited my last company and I had capital. So I was my own investor. I was my own VC, and
Knew what you're getting yourself into.
yeah. Well, I didn't actually. But okay. So I thought it would cost about 50 to 100 grand, and then fast forward 250 grand later. I'm constantly taking it out like, okay, well, we're in now, and now we're in too deep, and now we're in really deep, and okay, another 10 grand and it'll get over the line. And it was a huge undertaking, and far more than I'd even ever factored in. But we have got a great product, and our customers do love it, and they buy more. They don't just they come back and they keep buying our upgradable versions, and they like the software that we're coming out with. So yeah, I mean, okay, so how I would do it now is that if I could do it again and I didn't have an exit from a previous company, I would kickstart the hell out of it. But that is a myth in itself. Yeah. You can't just go on the platform with zero asking for $1 million. Yeah. You need half of that already funded. Yeah. You need to go speak to VCs who won't put money in hardware. You need to go speak to family and friends you might get a couple of $100,000 if you're lucky, but it's not enough. And if you have 50% of the fund already there, you're 90% likely to overfund on Kickstarter. Yeah. And if you have zero, you're 90% likely to fail. So there's all little tricks, for all of this. And it's, if you don't know that and you go on thinking, I've got this amazing idea, I'll tell the world about it, but I've got nothing on there, you're not going to fund it, and someone else will like that idea enough with the right amount of capital that they'll just build it before you. So there's a lot of risk with that as well.
Yeah, I think also as well is we talk about the US a lot, but if you go to the US, whether it be Ring or other companies, there's a great range of examples, whether that be software and hardware combined. And I don't see that in the UK. I don't see,
Doesn't exist.
And when I say that, I mean in terms of just being able to speak to people about it. So not even the money side of things, but if we were in Leeds and we went to our local entrepreneurial hub or makerspace, and you wanted to speak to someone that had been through this, like a Ring or another big company or company that's been successful, I don't think you'd struggle to find it. And correct me if I'm wrong on that, Dan.
No, you don't think they'd struggle? Or
You would struggle to find it. You would struggle to find it. And I think the businesses in here and generally in the UK are more representative of the service industry and the software industry rather than hardware. So even if you have the money, but you've got a load of questions about the pitfalls, who are you going to speak to? And I think in the US it's probably, and I know we keep talking about the US, but it's a little bit easier to speak to those mentors, people who've done it before. You've got people like Elon Musk, it makes it look easy, but
It's not eased to get a sit down with Elon Musk.
But there's role models. Just get him on Twitter.
Oh yeah. So, I'd have to agree. I mean, I'd say that we were on an IoT accelerator for the first one ever, and they took us to China recently, and that was nice. Nice to see that people are seeing the value in Internet of Things, connected hardware, and there was a small bunch of us. A couple of connected manufacturing machines into 3G and getting all the data out of it and saving the old-fashioned manufacturers like 20-30% of savings overnight just with this plug-and-play model. But people just aren't. I don't know whether they're interested or whether it's the risk averse. All that cash down and then no real return straight away. But then you could look at software the same way. Software developers are so expensive now that. Yeah. They're more expensive
especially
than
in
hardware.
America,
Like 70. I mean, if you're freelancing, some are getting £75 an hour plus VAT. It's like $1,000 a day.
So maybe what we've just discovered is a new type of VC in the UK. So maybe we should form this, which is investing in hardware tech rather than software.
Hard tech.
I like it.
If you take it to the government level, yes, we want to be a manufacturing nation. We're Brexit, self-sufficient. Be on the world platform. All those kind of buzzwords. But unless we encourage manufacturing and investment in these things at a low grassroots level, it will never happen.
So I guess we'll attempt to end on a slightly more positive note. So
this has been constructive.
It's been very constructive, yeah. No. So aside from don't do it, what if you could give one piece of advice? I'll go around the table to somebody who is maybe at the prototyping stage and is getting ready to go into the manufacture stage. What piece of advice would you give them, other than don't, other than run for the hills?
It's difficult, but 3D printing has made prototyping so amazingly easy now. And it's maybe £100 max, and you're going to have your product in front of a VC. So for letting them touch and feel it, that might just get them across the line. But using my previous track record, it absolutely won't get them across the line. I think we met 100 VCs, not one of them bit. So, but maybe we have a crap product. I don't know. I would say you can't really tell an entrepreneur not to do something, because if they want to do it, they're going to do it, and if they don't have the cash, they're going to find the cash, and if it's their destiny and their dream to do, they will. So there's no point in giving advice. People have to go through it the hard way.
My advice is that in terms of any business, and especially in the hardware business, the manufacturing business, the one thing as an entrepreneur, in my opinion, you've got to know your finances. You cannot, even if you've got a CFO, which you should have, a finance director,
a startup's not going to have a CFO.
Exactly, but you've got to know your numbers. And I don't just mean, I can make a spreadsheet with a bit of cash flow, and you've got to know your numbers inside out, because as soon as you have to pay a supplier or the supplier doesn't deliver whatever, you've got to be able to react. And if you don't understand cash flow, if you don't understand finance, if you don't understand raising finance, if you don't understand the debt models, if you don't understand any of that or the tools available, then you will fail if you have to rely on someone else. And that sounds like a really simple piece of advice, but the number of people who start up companies who say, I hate finances, never want to touch them, not my thing, they will fail because they don't understand the inherent thing that makes their business tick. And if you extrapolate that to a manufacturing business where everything becomes harder, riskier, bigger problems to solve, then you will just fail at the first hurdle. So the number one piece of advice is make sure you understand your finances.
My number one piece of advice would be, once you've got something manufactured, you're ready to sell it, that's not the end. You need to be wary of what your lead times are on the bill of materials. If you've got 152 items, how long will each of them take? Where are your reorder quantities? What do you need to do to continue to get product in your customers' hands? Because they're going to be the ones selling it for you ultimately, and if you upset them, you're going to lose face, the brand loses value, and you may lose that customer. So
Go do.
Go do. Power up.
Go do it.
So Leon, Dan, Joseph, thank you very much for contributing to this
Thank you
very
for
interesting
having us.
discussion. So if our listeners want to find out a little bit more about you guys and what you do, where can they find you?
Check out wifiplug.co.uk, and if you want to get a product or you want to get a couple, why don't you type element 14 into the checkout when you get there, so you can get a little discount.
If you'd like to find out more information about the Natwest Business Accelerator, just Google Natwest Business Accelerator and follow the links.
Yeah, so if you'd like more information about Additive Manufacturing Technologies and what we do, go to additivemanufacturingtechnologies.com. Alternatively, you can find us on Twitter at admantech, and that's it, I think.
And if you'd like to find out more about Element 14, including our own design and manufacture services, please go to element14.com. We are the world's largest online community of makers, engineers, and we are the official community of Premier Farnell. So until next time, thank you guys for joining us, and we'll be back soon with another edition of the Business of Engineering podcast. Bye.
Thank you. Thank you. Bye.